This video is going to work through problem number 25 in chapter 8 in detail. So let's take a look at this problem. You have a restaurant, and this restaurant's going to serve 50 dinner groups tonight. So the way to think about this is you're going to have a sample of 50 checks, if you will. Why don't we write that down? So n is equal to 50. Assume that the mean check size of dinner groups in general is $60 and the standard deviation is 40. Okay, so let x equal the amount of a single check. So we get one dinner party. What we know is that the mean of x is equal to 60 and the standard deviation of x is equal to 40. So that's what we've been told. The distribution is slightly skewed with longer tails towards high values. All right, so let's just draw that distribution. So probably don't have check sizes that are close to 0. But then we've been told that it's somewhat skewed, a little bit right skewed. So this is the distribution of x. This is called the population distribution. And what we know is that the mean of this distribution is 60, and the standard deviation of this distribution is 40. Part A, find the mean and standard deviation for the total of all 50 checks. So let's make a new variable. I'm going to call it t hat, which is equal to the total of all these checks. So in other words, how much money do we put in the bank tonight? So it's going to be the amount of check 1 plus the amount of check 2 plus all the way through the amount of check number 50. And we're asked to find the mean and the standard deviation of this total. Well, the mean of t hat, we have a formula for, is equal to just n times the mean of x. So this is going to be 50 times 60 equals $3,000. So in other words, we expect to put $3,000 in the bank tonight. You know, we won't put $3,000 in every night. Sometimes it'll be more, sometimes it'll be less, but on the average we're going to put $3,000 in. We also have a formula for the standard deviation. So the standard deviation of t hat is sigma sub x times the square root of n. So in this case, sigma sub x is 40 times the square root of 50, and this is equal to $282.84. So that's part A. Part B reads, find the mean and standard deviation for the average of all 50 checks. So in part B, we're going to have a new random variable x bar, and x bar is really just equal to t hat over n. So if we add up all the checks, divide by n, you get the average. Well, what's the mean of x bar? Well, the mean of x bar is equal to the mean of x, which is $60. So we'd expect an average of 60, just like we'd expect a total of 3,000. And what is the standard deviation of x? Well, we know that that's just sigma sub x over root n. So sigma sub x is 40 divided by the square root of 50, and this works out to be about 5.66. Part C reads, what further assumptions are needed in order for you to conclude that the total of all 50 checks is approximately normally distributed? Well, what you really need is a random sample, which means that all these tables are independent of one another. So the check size of one table doesn't affect the check size of another, and that they're identically distributed, and that they're representative of all such tables. So there's nothing special about tonight. This isn't Caribbean night where there's a special extra expensive menu or something like that. So this is a random sample of all such checks that we ever get. Part D, find the probability that the total of all 50 checks is more than $3,100, assuming that you can use the CLT. All right, so let's make this part D. And what we're asked to find is the probability that T hat is greater than 3,100. Well, let's go draw this over to the left here for a second. I'm going to put it down here. This is the distribution of T hat. And it's going to be normally distributed with a mean. We already found the mean is $3,000. The standard deviation is equal to 282.84. I think it really helps to remember the names of these distributions. So this is called the sampling distribution of the total. So keep the names straight. And somewhere out here is the value 3,100. And our goal is to evaluate the area in that tail. So using our central limit theorem, we're going to say that this is at least approximately equal to the chance of me having a z greater than 3,100 less the mean divided by the standard deviation, 282.84. Now, a real common mistake is to get the wrong standard deviation. So notice I got 3 standard deviations running around. I got the sigma sub x, I got the sigma sub t hat, and I have a sigma sub x bar. The way to keep them straight is to simply look here. What am I finding the probability of? Finding the probability of a t hat. Therefore, I want to use the standard deviation of t hat. That's another reason why I always write the standard deviation next to my distribution. That helps me not lose track of it. So if you do the math, this works out to be about 0.35, and you can go look up minus 0.35 and you get 0.3632. The reason it's minus 0.35 is I'm going to go use symmetry, and so this is 0.35 standard errors to the standard deviations to the left of that mean, and the area of that tail is the same as that one. So that's the answer to part D. Part E reads, what is the approximate probability that the average of all 50 checks is between 58 and 65? So part E is asking us to find this. What's the chance that x bar, the average, is sandwiched between 58 and 65? Well, I'm now going to go draw this distribution. I'm going to put it underneath this one because they have the same mean. Except this one, instead of being right skewed, is going to be normal, and it's going to be much less dispersed. This is called the sampling distribution of the mean. And just to keep us straight, let's write our standard deviation here, 5.66. So somewhere out here is the value 58, somewhere over here is the value 65. What we need to do is evaluate the area in the middle here. So we're going to do the old trick. Remember, normal tables never answer anything but less than questions. So we can find the chance that it's less than 65. We can find the chance that x bar is less than 58. What we care about is this area in the middle. So this is going to be the same thing as us having a z less than 65 minus the mean divided by 5.66. Okay, that's that first arrow, minus the probability of us having a z, that's a z, less than 58 minus 60 divided by 5.66. And that's that other arrow. So the difference is going to give us the piece in the middle. If you go off and do the math, this is 0.88. This is minus 0.35. go look up those two numbers in your normal table. So you get 0.8106 less 0.3632. So the final answer is 0.4474. And that is the area in that slice in the middle. So that's the problem number 25 in Chapter 8.